We're going to speak about quality of data. So, Alfredo,
Shalini is here.
Grazie a voi, un saluto Alfredo. Saluto.
Buona giornata.
Hi.
Let me introduce Shalini Kurapati. She's a co-founder and CEO of Clearbox AI. Shalini is a multidisciplinary expert in the intersection of technology, policy, and management. Shalini entertains us about professional Europe with demonstrable knowledge of the GDPR and European privacy laws. Thank you.
So, thank you. Good morning, everybody. Thank you for your warm welcome and this opportunity to share my thoughts on data quality, privacy, and fairness. So my talk today, as I was kindly introduced, I'm the CEO of a company that produces synthetic data for data quality and privacy. The idea of today's talk is to kind of talk about, can we do innovation while being responsible, while following the regulation? Because we always have these two thoughts that either we follow the regulation and compliance and we don't do anything, or we innovate and forget about all the regulations or all the ethical aspects of it. So today, I would like to kind of, introduce what we are trying to do at Clearbox AI, also with our solution, is about business applications of innovative solutions that can both create innovation and also protect all the necessary regulations. So first, I am an engineer by training. I'm not a lawyer, but I've got very interested in the data privacy and ethics a few years ago. And since then, I've been very much into how are we going to bring the principles of regulation into technology, because one of the biggest problems is data scientists or people who build the systems want specifications. They don't want frameworks. They don't want checklists. They want to have specifications on how do I implement privacy. So I was trying to be the bridge in these two. So let me start by introducing what is synthetic data. Maybe some of you already know about it. If not, it's basically fictitious data. It's usually generated by algorithms, an AI algorithm in our case. There are many ways of synthetic data. You have generative data where you directly generate from scratch, but what we do is not that. What we do is we take an original data set and we create a kind of a clone of it while preserving all the statistical properties of the original data set. At the same time, we also preserve the privacy. So there's no one-to-one direct identification. There are other privacy risks, which we also quantify, but this is basically the scope of it. And this falls very much within the paradigm of what the so-called data-centric AI, artificial intelligence, because nowadays, everybody talks about large models, like, million parameters, billion parameters, I mean, to exaggerate. But the idea of shifting from model-centric AI to data-centric AI, if you are following Andrew Ng, the expert of machine learning from the US, he had a very interesting talk where he was saying that 80% of the time spent by people who build AI models is spent on data, on acquiring data, cleaning data, understanding the quality to make the data production ready. And only 20% of the time is spent on, making the models perform well. However, most of the innovations are happening on the model side of things and not on the data side of things, because, ensuring data quality is the least sexy of the jobs in the whole cycle. So the assurance of quality, or trying to understand how to ensure data quality and privacy and all the ethical aspects that come with it are very much neglected, with a lot of focus on the model. So in the data-centric AI of things, we can see synthetic data as one of the advances in that aspects for two main reasons. One thing is having access to real quality data sets. So most of the machine learning models fail because they can't basically access data for a number of reasons. It could be because of organizational silos. They don't know, oh, can I give this data to you? I'm not sure. This ownership, understanding who has control over the data. Not every organization have data lakes that have centralized data resources, and they could be fragmented into departments. Even if you look at a hospital, for instance, different departments might have different types of data as well, what they collect. So multi-modal, multi-data sources. There's so many organizational issues and also culture issues about, even if regulation doesn't play into place. And then you also have regulation where you might not be allowed to share data because of privacy reasons. So having access to good quality data impedes good, robust AI model performance, because you can start building models with toy data sets, but if you want for them to really work, you need real data, at least real looking data. And that's one place where synthetic data can help, because you are kind of creating realistic data sets to train your models, especially for model training purposes, while protecting privacy. And the other aspect, which is also related to model performance, is the imbalances in your data set. Because when we talk about data quality, a lot of people mean a lot of different things. You have metadata quality, you have semantic quality, and it's so different for different data sets, different types of data. You have tabular, time series, images, text, and for each of them, what quality means is very different. So you need to have, and especially we are talking about, if we talk about tabular data sets, we're talking about millions of rows of individuals. We work with banks, for instance, Banca Sella and Generali have used a solution for data privacy reasons to build their AI models. And there they have millions of transactions of their customers, and they want to protect their privacy while improving their services. And here, another issue we have is that not all data is good quality data. What does good quality mean? I can give you an example. For example, if you are thinking about developing an algorithm to detect frauds automatically, you will need to teach this algorithm what a fraud looks like, because algorithms require a lot of data for you to tell them this is a fraud, this is not a fraud. This is a fraud, this is not a fraud. It's like you have to do it multiple times. But then the real data that you have might not have so many examples of frauds. Thankfully, in the transaction data, only a very small part of the transactions are actually fraudulent. And you'll have to teach this algorithm, and maybe these few numbers are not enough for the algorithm to be robust. So you might end up having a lot of false positives or false negatives. So what we also do with that is this, we call it the imbalances as well in the data sets. And here, we can also augment the number of fraudulent cases. We can create more fraudulent examples for the model to understand what happens. So this is more on the privacy and the data augmentation side, which is less, more obvious. However, this has a very strong link also to fairness and bias in datasets, because what I told you about the fraud detection of having fewer examples for fraudulent cases, but if you translate that also to the more ethical aspects of it, I can give you an example. Let's say in a medical domain, if you want to create an algorithm to diagnose a particular ailment based on your symptoms, like you put your symptoms and the algorithm should tell you what do you have. There was an example of a startup in the UK which had an app for that, historically the human body was studied upon a man from the Western man. Okay, even historical textbooks, medical textbooks have been on Western men. So in many textbooks, you might notice that the conditions of women for similar things are always called atypical. So this is an atypical condition, which how can you call 50% of the population atypical? And these things can propagate also into data. So for instance, heart attacks for men, the symptoms of heart attacks for men are very different for women. And if you don't check the quality of data and see these differences, you might end up, which also happened with the app, when a man put his heart attack symptoms, which are chest pain and this kind of stuff, the contraction of stuff, and the app immediately told the man, hey, call the emergency service and you need to go to the hospital. And for women, it's different. They could have back pain, some clinging aspects. And when they put that, they said it's a panic attack, calm down, stay home. So you have this kind of bad data giving possibly life-threatening decisions. It might seem banal, but so the data quality is not just about performance or privacy, but it also has real impact on human beings. The same thing also happened with Apple credit card, less life-threatening but equally bad, which is the fact that the credit scoring in America is calculated. Credit limit for you is automatically calculated. And in the same household, a husband and a wife, they had exactly the same kind of jobs, the same bank accounts, shared bank accounts. And the only difference was that he was a he and she was a she. He got 10 times the more credit limit than the woman. Which is completely unacceptable, because it was a clear case that the only difference there was the gender. So, and this also in terms of recruiting, in terms of criminal justice, if you're going to use algorithms, you might be kind of training these algorithms probably on bad data. You have different the reason why you will have bias comes from so many different aspects. It could be model, it's from the society, it's all interrelated, of course, but the good part falls upon data, at least the ones that we can control a bit more than the others. So it's important to also look at data, both from an imbalance side and also fairness and ethics side, where you can understand which attributes you want to protect and how do you want to look into. So companies, what we think, that there are no right answers for how you do it. For example, what we do, we don't just approach it from an ethics perspective. We are also pragmatic in terms of this is not only good for ethics, but it's also good for your models. If your model is being wrong, you might be losing female customers. You might be, having reputational damage for something that could have been avoided. So the first step, what we do is what we call data profiling. It's an automatic test to do some sanity checks on your data set. So you can kind of write a data set. You expect the data set to look like this. So, and then you write this test. It's based on an open source library called Great Expectations. We have this open source. If you're welcome to check out on our GitHub, our data profiling library for structured data. So you can write a check. You can see that, okay, this column, I expect that column C should be a match, an addition of column A and B, and it does a check for all of this and tells you, yes, it's there, or there are some errors there. And then you can go and see automatically how do you fix these errors. So, and also it's the same for duplicates, it's the same for strange situations like, I don't know, if you see it, you can also spot that if you say there is a 15-year-old widow, that sounds strange. So you can write also specific examples to remove such information. So what we try to do is we try to, in the whole ecosystem of imbalances, fairness, and bias, we have the human bias, the systematic bias, and the computational bias. We as engineers understand the systematic and human bias, but try to, model it in the computational side of things. How can we, reduce the impact of, perpetuating the wrong things? So we first do the profiling. And then for the, we try to also balance the data sets using our technology. And the most important thing we definitely like to do is to kind of also have a multi-stakeholder approach, because it really depends on the expectations of the company. So what are your expectations? Is it model performance? To what level are you willing to take the trade-off between performance and fairness? I'm happy to say that in many cases, better fairness also means better performance in their models in many cases, because you're actually increasing the true positive rate based on better fairness metrics. And then it's also a culture shift towards data quality, not just models. Look into your data, make sure that your data is of good quality. And it's a tool to automatically improve, or at least find out what's wrong with your data. And also the focus on testing and more testing. And there are no perfect ways, of course. For example, in our commercial offering for privacy and data augmentation, we can be very, very objective. We can tell you, these are the metrics, this is the things you should do. But for fairness, there's a lot of imbalances. It's a lot of cultural aspects. So it's a much more of a discussion rather than just implementation. And there are no really perfect ways. And I would like to close the session with a quote by William Bruce Cameron. And he says, not everything that counts can be counted, and not everything that can be counted counts. So it's about understanding this in a fairness perspective. So I would like to conclude my talk here, I think, and happy to answer any questions.
Thank you so much, Shalini. Any question out there from someone? And Andrea Calderini, you can speak directly, please.
Of course. Thank you, Shalini, for your speech. This is a super important topic for real data and synthetic data about privacy. As I know, in computer vision industry, real data are can help training the model much better than synthetic data. And so my question is, could you say something more about the processes behind the quality of how to improve the quality of synthetic data? Because I see them like the substitution for the privacy, as you spoke, but the performance are sometimes quite different, at least in computer vision. I don't know in
no, absolutely. I think it's a very good question. Like I said, there are different types of synthetic data. Like what I see for computer vision is a bit more of simulated images rather than cloned images. Because, for instance, if you talk about autonomous driving, you do need massive amounts of data to train your or self-driving cars, if you may. And it's very both cost-effective and also safe to actually use synthetic data, because there are also many studies also done by NVIDIA that say that if you try to collect so much data manually, you might even put a lot of people at risk for different situations. So it's also a safer and efficient way of doing it. In terms of quality controls, like, for example, I can talk about our domain. What we do, especially when we clone our synthetic data, is we do what we call, there's a particular name for a metric called train on synthetic and test on real. So you can actually understand how well the synthetic data is performing with respect to real data. So it's always important to have at least a small set of real data sets to kind of compare about how it works. So there are also other metrics, but the quality, that's a very good question about quality. Not all synthetic data sets are of good quality. You do need to have a procedure to check also those quality. And especially we do that in terms of how well it performs on the model, and including all the other data quality checks that I've spoken about.
Thank you. Obviously, the objective, for example, accuracy will mean a lot in the quality.
No, absolutely. Yeah, definitely.
Thank you so much, Shalini.
No problem.
Shalini, I have a question. Could your synthetic data be used in contrasting the adversarial data?
Adversarial attacks?
Yeah, thank you. Yeah.
Well, I think. Okay, well, adversarial attacks are much more of a computer, in my opinion, a computer vision problem, a lot more than in structured data sets. So I cannot directly think of a specific use case for adversarial attacks, but we also, here is something which we also need to mention, is that the concept called predictability of AI models, that is very much related more than the data itself, because we assume that AI models are predictable. Like we cannot assure that they're 100% predictable. I'll give you an example. For example, if you have a Tesla car, there was an incident where it saw the moon and thought it was a traffic light. It's not necessarily an adversarial attack, but it's just that it was we couldn't model that into the system. So I think it's a comprehensive aspect into how much we can expect the systems to be predictable. So I think it's a system issue rather than a synthetic data problem.
Thank you very much, Shalini.
Shalini, just a few seconds about sharing somewhere with us, with the organizers of this event, about the foundations, where each one or the technicians around us can have some education online, or what book you suggest to start about the synthetic data field?
Because synthetic data, I would say, is really up and coming. There are, in terms of, I mean, it's been there for a while, but there is no, and there are also so many different, domains of it. However, I do suggest a book called Practical Synthetic Data Generation. It's written by a professor in Canada. He's actually a medical professor.
Okay,
please,
I
can share you the link.
Yeah, please chat us.
Because but it's a bit more technical rather than but it's very useful. I mean, I found it very useful to kind of implement it. So it's this book I definitely implement.
Okay, great.
And also the European Data Protection Supervisor, I can also share the Taxonomy report.
Okay.
Recently, they talk about different technologies, among which synthetic data is one, about privacy preservation. And I can also share that with you, and might be useful. Yeah.
Okay, thank you. Thank you. Thank you.
I have a curiosity, because I have recently had focus on federating learning approach. So I'm wondering if you have ever considered the integration between the synthetic data and a sort of federated approach in order to provide ensure privacy.
Yes, I mean, I think it's a good question. I have a feeling that they are not, they could be related, but they are very different in terms of how they look at privacy, because federated learning requires a lot more buy-in from a lot of stakeholders, and you might require like a trusted third party to coordinate the model training. And the risks associated with federated learning, in my opinion, can also be slightly higher, because sometimes if you have a model, you can kind of reverse engineer about what the data set looked like. So the privacy risks are also very different how we calculate that with synthetic data. So what we do with synthetic data is really about, the scope is a much more on a specific set of information rather than an entire group of stakeholders where you might need your model to go to every one and learn it. And the way we see privacy risks are also very different, and the scale is very different. So I have to think about how it could be integrated, but like I see them as kind of different.